In this video, we will learn how to work with the VS Code debugger. First, let's try to compile our project. I'm going to use make homework 1 as explained in the previous video to compile the project. I see that we have a bunch of these compiler errors, and this time I'm going to resolve only these errors. So I will go to eliminate.c and I will comment out these variables that are not used. So iter will get commented out, so will step, and cake fans. Now let's try compiling again. And we see that it successfully compiles. Going back to the makefile, we see that there is a target called test%. The way this works is that you can enter a command as follows, say make test1, and this command will substitute this number 1 wherever you see the $. So if I run make test1, I see that the program is still executing, and it's still executing, and it is still executing. So this looks like there's an infinite loop because this program should not take anywhere this long to run. So I'm going to stop the program with Control-C. Then I will try to debug the infinite loop using the VS Code debugger. To do so, go to the Run and Debug panel and click on Create a launch.json file. Select debugger, this will be C++, and then click on GDB launch. This is going to generate a list of configurations to configure GDB to run when you launch your debugger. We're going to have to make a couple of changes here. So first, get to this line with program, and then delete this and change the name of the executable to homework1. The rest of the configurations can be left as is, but as a note, in future homeworks, if your program takes in command line arguments, then you might want to put them in here. As say arg1, arg2. So these command line arguments will be passed to your executable when GDB starts it up. However, for this homework, there are no command line arguments accepted. So these argc and argb are not used within this program, so we don't need to worry about that. Instead, what we notice is that we're taking in the arguments using scanf, so when we run the debugger, we'll have to provide these. So let's run the debugger to test that. One thing you need to note before you run the debugger is that you need to set breakpoints. Breakpoints essentially tell the debugger where to stop and where you want to start looking around and poking around the program to understand what it was doing. Here, I'm going to set a breakpoint on line 27. Now, we're good to launch the program in the debugger. So click the play button. And now the debugger should get launched. You will see this ribbon up here. This is mainly what you're going to use to control the debugger. So let me just try restarting it. So now you should be brought to this terminal here, this empty terminal, where you're going to enter in the arguments to pass into main. So if you remember, I said that main.c takes in arguments using scanf, so we'll have to provide those arguments through the terminal. So let's just provide valin and valk as 6 and 3. Now you can see that the program has started executing and has come and stopped on line 27. Now, once you're here, you have a few options. You can either choose to continue execution, or you can choose to step over to the next instruction, or you can step into the current instruction, especially if it's a function, or you can step out of the function, or you can restart the entire program, or you can stop debugging. Let's go through this one at a time. Let's first try to step over this line. So when I press step over, all it does is it finishes executing the current line and then goes to the next line. If I try that again, step over, I'm going to the next line. And if you can see here, these variables were updated. So eliminated was set to be 0 and so was counter. Next, let's see what happens when I press continue. So it looks like the program is now stuck in an infinite loop and is not finishing its execution. Let me try to pause it. And I see that it's still stuck right here at this while loop. So that is odd. Let's see what this while loop is doing. So the while loop is checking for when eliminated is less than n-1, eliminated is 0, and n-1 will be 5, so that condition is true. And then inside the while loop, nothing happens to eliminated. So this condition is always true. So the while loop essentially keeps running forever, and that's the source of the infinite loop. So I think we found the problem. So how can we resolve this? Well, without spoiling the solution to the homework, one way we could solve this is by just incrementing eliminated every time we're in the loop. So let's do that and then test if that solves the problem. Let me exit out of the debugging session. And then let me increment eliminated here. So in every iteration of the while loop, eliminated gets incremented by 1. Let me recompile the program. This is very important, because otherwise you would try to be debugging the old version of the program and you wouldn't see this updated line. Once we have recompiled the homework, let's go back and launch GDB. Enter our program arguments, 6 and 3. And then we come to eliminated. Let's go to the next line and the next line. And let's now keep an eye on eliminated. So let's look at this panel a bit more carefully. Variables stores all the local variables to the function and displays their values. If you want to focus on a particular set of variables, you can use the watch tab and add an expression. So I want to focus on eliminated. The call stack will show all the functions that have been called before, and then breakpoints lists the breakpoints that we have inserted. We really don't need to focus on the breakpoints. We're just going to focus on these 3 panels here. Now I'm going to continue through the execution by clicking on step over. And now I see that after the first iteration, eliminated has changed from 0 to 1. This is promising because this means we're not stuck in an infinite loop, hopefully. So let's keep going. Eliminated has been incremented to 2, 3, 4, and 5. And now we've broken out of the while loop. Well, that's because the while loop was checking if eliminated was less than n-1. N is 6, n-1 is 5, and 5 is not less than 5, so this condition is false and we break out of the while loop. So that way, we're actually solving the problem of the infinite loop. So if I press continue, we should finish executing the program, which you can see here. To confirm, let's go back and try running make test 1. So we can see that we finished executing, but we did not get the correct answer. That's because we didn't really solve the problem, we just fixed the infinite loop. Another thing I want to demonstrate is how to use the step in and step out options. So let's remove this breakpoint in eliminate.c and go back to main.c and put the breakpoint at this if statement. Let's try running it again. Provide our arguments to the program, 6 and 3. And now, watch what happens when I step over. I have an eliminate call here, but then when I step over, I don't go inside the function. So I would not be able to debug what's happening inside eliminate. Instead, what I'd want to do is, I'm restarting the program and passing the arguments again. So what I'd want to do is step into the function. So this is going to get me inside, and then I can start debugging here. Let's say I figured out the issue and I want to see what happens when it continues executing. I will use the step out function to exit out of this function. So now I'm back here. So step in allows you to go one level deeper into the call stack, into the current function, while step out allows you to come out of the current function to its calling function. That's how you use the debugger, and it's a very powerful way to debug your programs. It's much faster than print debugging because you know exactly where to go and you don't have to keep adding print statements and recompiling and running the code to find out where you've gone wrong. In the next video, we will go over pushing your code to GitHub and how to maintain your files and homework repository.